are going to talk about equilibrium more and how we can use the equilibrium to constant to perform calculations. So let's look at the solubility equilibrium first. Solubility equilibrium is looking at ionic compounds and how soluble they are when they're dissolved in water. So arsenic that occurs naturally in minerals can dissolve into the groundwater, and it does so a sulfide. So we have arsenic sulfide in water. It can break up into arsenic ions and sulfide ions. This is a mineral showing the arsenic with as it exists in rocks that can leach into the groundwater. And this map is a US Geological Survey, which monitors the amount of arsenic found in untreated groundwater. So the areas with red have a higher concentration of arsenic in groundwater compared to the green areas. Notice that when you are writing the equilibrium reaction for the solubility, I have a solid going to aqueous. So the solid will not exist in my equilibrium expression. And I can write an equilibrium expression for this process. It's going to be the concentration of arsenic. I forgot to write that arsenic up here. There we go. It's going to be the concentration of arsenic ions, concentration of sulfide cubed. So it doesn't depend on how much of the arsenic sulfide is in the minerals in the ground. What it only depends on is the concentration of the arsenic ions and sulfide. It's hard to read. There we go. So and perform calculations to determine how much arsenic could be present in groundwater. So we can calculate the concentration of arsenic in groundwater if a sample of groundwater has a concentration of sulfide of 0.0010 molar. And then I have the equilibrium constant for arsenic sulfide. So remember, we have our equilibrium equation. So we have two arsenic ions, sulfide ions. And we can use the equilibrium equation to come up with our equilibrium expression. So K is equal to concentration of arsenic times the concentration of sulfide. I'm trying to solve for the concentration of arsenic. So if I rearrange my equation to solve for the concentration of arsenic, I'm going to get the square root of K over the concentration of sulfide cubed. And now I have a plug and chug situation because I have K That is 1.2 times 10 to the negative 16. And I have S is 0.0010. And I'm going to cube that. And then I can take the square root of all of that. So go ahead and plug that into your calculator and let's see what we get. Um, all right, with your calculation, I get 3.5 times 10 to the negative 4 molar. So this is an example of how you can use the equilibrium constant and the equilibrium concentration of other species in equilibrium to determine the concentration, the equilibrium concentration of something within your system. Let's look at another example. So, equilibrium system of the dissociation of acetic acid. Write the equilibrium expression for the dissociation of acetic acid in water. So this is going to be K equals the concentration of hydrogen ion times the concentration of acetate divided by the concentration of acetic acid. Calculate K for acetic acid if we have the following concentrations at equilibrium. So again, this is just going to be a plug and chug situation where I plug my numbers in and then I chug it out on my calculator. So I have 0.0010 times 0.0010. They're the same, so you could think of it as, and then we're going to divide that by 0.05. Then get your calculators out and see what 1.8 times 10 to the negative for the equilibrium constant. The equilibrium constant does not have units, so you do not have to put units on your answer. Notice in our previous example, we did put units on our answer, but we were not solving for the equilibrium constant because we were provided with that, and we didn't have units on that. We were asked to solve for the concentration, so we have units of concentration. If you're solving for just the equilibrium constant, then there are no units. And for the dissociation of lead 2 chloride in water according to the following reaction. So again, I can write my equilibrium expression. It is going to be the concentration of lead 2 times the concentration of chloride. We want to calculate the equilibrium concentration of lead given the following. K is 1.65 times 10, oh, this should be to the negative 5, and chloride is 0.010. Again, we have a plug and chug situation, but I need to make sure I'm solving for the concentration of lead. And that is going to be equal to K divided by the concentration of chloride. So my plug and chug situation is going to be plugging 1.65 times 10 to the negative 5 for K and 0.010 in for chlorine. I'm going to make sure to square that. We plug that into our calculators. And what do we get? 5.75 molar.